This video is going to focus on some things that you might already know, and that's okay if you're hearing them again because these are things that you need to know in order to move forward with the rest of this material. So let's go through some basic types of definitions, and once we do that, then we can use them in other things. So chemistry is the study of anything that deals with matter, and matter is anything that has mass and occupies space. And as you might know, matter and energy are also related, so we deal with energy too. Pure substances are, it's like there's only one thing in that pure substance. It's kind of like the word says, but there's different ways to look at this. So there is elements, and those are on the periodic table. Technically speaking, when elements combine into like having two of the elements together, we call that a molecule. I didn't include that here, but that does also exist. And then we have things like compounds, which is when you have two or more different types of elements or atoms that are joined together in a fixed ratio. So what that means is like water has 2 hydrogen, 1 oxygen, and the position does matter too because it matters like which atom is bonded to which. That can make a huge difference as we move forward. Okay, so next we have mixtures. Mixtures are like 2 or more things, 2 or more substances that are combined. And we can have those occur in different ways as well. So we can have a homogeneous mixture. Homogeneous mixture is something that has the same consistency throughout. It could be salt water, lemonade. Air is a mixture of different gases. And what you may not realize is that air is a solution. You may have thought that a solution was only in liquid. That's not really the case. So air is a solution. If you have metals that are mixed together in what we call an alloy, that's also a solution. But most of the time when we talk about solutions, we're talking about liquids. Just realize that has a broader definition. And then we have a heterogeneous mixture. So these are things that are mixtures that they're not the same throughout. So oil and vinegar, trail mix, things like that. Okay, next we need to talk about what states of matter really are. So a state of matter you probably know as solid, liquid, and gas. And just to review those a little bit, there's also a 4th state, and that's plasma, but I didn't include that here because it's usually in stars, so we don't really encounter that so much on this planet, although you may be familiar with a plasma TV. As far as this course is concerned, we're probably not going to deal with that very much, though. Okay, so solids have a defined shape. Their molecules are still moving. They're just in a close arena, right? And they're fixed and they're not going to move very much. So they're kind of moving really slowly. They might vibrate, they might jiggle and wiggle a little bit, but that's pretty much it. The volume of a solid is defined. Liquids, their shape forms to that of the container. So the shape is more amorphous and the volume though is defined. So these have atoms that are moving more around. They may like interact with each other a lot and not really stay in one type of position. And then finally we have a gas whose shape and volume fills the container. So what that means is that you don't have all of the atoms of a gas move to just one side of the room. They spread out and they're moving very, very quickly. And we're going to talk about gases as we move forward later on. So these tend to also have atoms that are very far apart, or molecules are very far apart. So that's another thing to know there. So when we change from one state of matter to the other, that we refer to as a physical change. And that could just mean, ice melting or water boiling. Those are physical changes. Sometimes that can be a little bit more tricky though. Like wood burning is not a physical change. That's a chemical change. So chemical changes happen when you actually have one substance turn into another. Keep in mind, wood, when it burns, is turning into CO2, it's turning into water, it lets off heat, and you get some ash that's left there. But that's a little bit different stuff. So we can also talk about properties. So a physical property is one that reflect the identity of a substance. Density is a physical property. And then we have things that are chemical properties. So these are like a description of how chemical reacts with another chemical, or what type of thing it can combine with, stuff like that. So to measure some of our stuff when it comes to energy, because this is temperature deals with stuff and energy, we need to measure temperature. So temperature can be measured in different ways. We can use Fahrenheit, mostly in the US. We can use Celsius, and we can use Kelvin. So we typically measure in Celsius in a lab. Just to go back and mention, temperature is technically the average kinetic energy of a substance. So that's how much its atoms are moving, and we measure that and call it temperature. It's kind of cool when you think about that. So, okay, we have different ways to convert from Fahrenheit from Celsius, or we can convert from Kelvin from Celsius. Something to note, the 32 is exact here, as is the 9/5, so you don't have to worry about sig figs in these problems. So I just threw up an example here. If we have standard body temperature is 98.6, we can convert that to Fahrenheit using the equation that I just showed you. Keep in mind that when you go to use this equation, when you have this 9/5, to get that out of both sides of the equation, you would need to multiply both sides by 5/9, because that would cancel out the 5 and the 9. Okay, just pointing that out. And we're going to answer in 3 sig figs here because that's what we started off with. Everything else is exact. And then if we have this 37 degrees Celsius, how to convert that to Kelvin, we just have the 273.15, and we should put that in as 310 with a decimal degrees Celsius. Okay. Thank you very much. I hope this is helpful. Let's move on to energy next.